Welcome back to Excellence Icon, and we are starting within the chapter number 14 of your CI Chemistry. Alright, so we are starting the organic chemistry, and I hope so that everyone has joined almost. And if you are having any problem related to your organic chemistry, you can comment me below. And in your biology, you were already aware of your organic and inorganic compounds in your chemistry for O level. We have already discussed about what is the acid and alkali, about the hydrocarbons in our chemistry. Did you remember about it? So we are required to understand about some structures and about some bond, the groups, and we are required to determine from which group they belong to. The structure is given to you in the question. So in the organic chemistry, I hope that this must be very easier if you understand the groups. Okay. In this organic chemistry of AS, you're also required to name the compound by yourself. It means that you are allowed to just identify the structure and give the answer or just name it according to your sense. And this is one of the interesting chapter. All right. This is the formula functional group and naming of naming organic compounds is something that you comfortable with in order to understand the rest of organic chemistry. You are required to be able to name organic compounds which have up to 6 carbons in a chain, such as for the one you have already known as METH as meth, and then for 2, if the carbon number is 2, so it is eth, and if 3, so prop, 4 for but, and pent for 5, and then hex for 6, hept for 7, and oct for 8, and okay. There are different ways in which an organic compound can be displayed: molecular formula, structural formula, skeletal formula, and displayed formula. From the molecular formula is the actual number of atoms of each element in a in a molecule. For structural formula shows the structure carbon by carbon with hydrogens and functional groups attached. Skeletal formula only shows the bonds on the carbon skeleton. The carbon and the hydrogen atoms are not shown by any functional groups are. It can be used to simplify large complicated structures. Displayed formula shows how all the atoms are arranged and every bond between them. Examples of these different types of formula can be seen in the table below. Alright. Homologous series is a group of compounds with the same functional group, with successive members by differing carbon hydrogen 2. Homologous series halogen alkanes and alcohols, aldehydes, ketone, carboxylic acid, esters, amines, and nitriles. Alright. Now we are required to focus for the prefix used for alkanes to determine whether it is alkane or alkene is that ane. Okay. If it is alkene, it will be ended by the prefix or suffix as ene. For halogen alkanes, it is at the starting, such as fluoro, chloro, bromo, or iodo. Such as, for example, names propane. If it is propane, it is an alkane. If it is it is a alkene. All right. As we already discussed in the previous live session, that alkenes are the uh, uh, unsaturated hydrocarbons, and alkanes are the saturated one. All right. For the halogen alkanes, you can see the name chloroethane, and the fluoro, chloro, bromo, or iodo is always before the name of the group. All right. For alcohols, as we already discussed about the cholesterol, as it is an alcohol. Why? Because at the end of cholesterol there is OL. It means that OL at the end, such as ethanol, will determine that this belongs to the group alcohols. All right. For aldehydes, it is ethanol. Okay. For ketones, it is ONE, again propanone. For carboxylic acids, oic acid, such as ethanoic acid. All right. For esters, it is alkyl OH, means uh, who is having the methyl. How can you just determine this methane ethanoid, methane and ethane? For suppose, so now you're required to just understand that the methane will be having the word methyl and the ethane will be having the word ethanoate. Methyl ethanoate. It is the word for the carboxylic. It is the word for the esters. For amines, it is methylamine. Simple amine word will be added. And for nitrils, ethane nitrile. You can also focus on the molecular formulas, which are simple as shown, structural formulas, which are also simple as shown. What is the skeletal formula is a bit new for you guys. In this first, you can see that there are in the molecular formula and the structural formula, there are the only three carbons. So this is what you can say an arrow. In this arrow, you can see that there are the 3 points. All right. So this 3 points shows that alkane in this alkane of propane there are three carbons, and we are all just required to just show the zigzag lines, and every zigzag line will show the carbon atoms. We are not required to write anything else. All right. And the displayed formula is one of the essential formula for the determination, as you can see from the alkenes. Similarly for alkenes and for other homologous CVs. In the alkenes, you can see that there are the double bonds shown to you, and there is no zigzag lines connected. This means that there are two carbons and both have the double bonds. You are also required to show the double bonds in the skeletal formula for alkenes. In the displayed formula, you can see that the double bond is visible to you in the both carbon atoms. For halogen alkanes, you can also see that in halogen alkanes there is a chloroethane. It means that there is a three. It means that there are the two carbons, as visible to you from the structural and molecular formula. So the skeletal formula must be one line which consists of two carbons and another other line which is connecting to Cl, and you're required to just write the Cl for determination of the chlorine, and here is no carbon present. It means that there are two carbons and one chlorine. It means that it is chloroethane. All right. Plus in the displayed formula, this is also shown to you. In alcohols, again the same thing happening, as you can now just see that uh, there are two carbons in the molecular formula and structural formula, and in the skeletal formula there are two carbons on the one line, and there is OH group, hydroxyl group. Understand? So this is very important to write. If you does not write or you forget, so the examiner will consider this line or this line also as a number of carbon. All right. For aldehydes, as eth there are two carbons as shown in the structural and the structural and molecular formula, while the skeletal formula is a bit visible to you, as you can see that there are the double bonds. Okay. This sorry, it's not having the double bonds, it's having the, yes, the bond, but not for the carbon but for the oxygen. Yes. And you're also required to just show in your structural form in your displayed formula, it is very visible to you that there are one carbon which is having the double bond with oxygen. It means that this is aldehyde. All right. Okay, wait a minute. And now we are required to just see this ketone, such as propanone. And this propanone, you can consider this structural formula as shown, sorry, structural skeletal formula as shown to you, that there are three carbons. All right. So the three carbons are visible to you in your skeletal formula, and one which is having the bond with oxygen. Okay, as shown to you in your displayed, in displayed formula. If you are feeling any complication in your making of the skeletal formula, you can just draw for a rough working. You can just draw the displayed formula, and then you can just determine the number of carbons, and then you can just draw the lines according to the number of carbons. Remember not to draw the straight line, draw zigzag lines so that you can the number of carbons must be visible to you. In the carboxylic acids such as the acid, there are two carbons, and the ethanoic acid. So here now you can see that this is the double bond with oxygen and hydroxyl group, means carboxylic acid. All right. By the displayed formula, it is much visible to you and much easier for you that now you're required to just make the two carbons and one which is the OH, which is not considered as carbon, and same for esters, amines, and for nitriles. Here in the nitriles, you can also observe there are the triple bonds visible to you in your skeletal and displayed formulas. All right. Okay, and what is this? Wait a minute. All right, so this is only for the A levels. So we are just only understanding about the AS organic chemistry. Yes, we are only just understand about the uh, AS chemistry. And the naming organic compounds. Now there are some rules you are required to just follow to name the compound. Identify the longest carbon chain that contains the functional group. Identify the functional group on the chain. This gives you the suffix or prefix of the compound. Count along the carbon chain so that the functional group has the lowest number. See the example below to illustrate this. If there are any side chains, like R chains, add these as prefixes, such as methyl, to the beginning of the name. Do the same if there are other less important functional groups. Put these at the start of the name in alphabetical order. Means if it is A, B, and C, you're required to just move one A and then write the B and write C. Means the words from this alphabetical order. If there are two or more identical functional groups or sites, di, tri, and tetra before that section of the name. Just read these examples for further clarification. The longest carbon chain is 6 carbons long, so the prefix is hex. For the 6 carbons, it is hex as for the determination I talk you from the first of the point. The most important functional group on the chain is OH alcohol, as visible to you guys. All right. Now from the suffix is therefore OL. Now you can see that C2, C3, C4, C5, C6. How it is number the carbons, so that you can you can feel easy to write as from C2 carbon 2. Okay, so from the carbon 2 is visible to you the hydroxyl group. All right. So now from the functional group, wherever the functional group attached to the carbon, so you're required to just mark the numbers according to the from where the functional group is attached to the carbon. Such as from in this case, the hydroxyl group is attached to the end of the carbon, so we are required to just start the counting from end. Okay. And then the alcohol is on the second carbon in the chain. Count from the second closest to the suffix becomes to ol. OOL means, and it is where it is present in the second of the carbon. So this is the position. All right. There are two sides and ethyl on the third carbon. So it is 3 ethyl amethyl on the fifth carbon. CH3 and C. All right. So this is visible to you. Sorry, CH. Yes. CH2, 3 and CH, okay, 5. Place the prefixes in alphabetical order and add them to the name. The name will be 3-ethyl 5-methyl hexanol. Do you understand? 3-ethyl means ethyl is the group present at the 3 carbon. It is a position for the ethyl. For methyl, it is located at the fifth of carbon, as visible to you in the diagram. So it will be having the position of 5 methyl. And then hexanol means the 6 carbons, and OL means the hydroxyl group. All right. Do not worry. In our second live video, soon drawing the diagrams for more clarification. All right. So okay. So in this case and in previous case, I was just confused because of only just the reason that the structure is not complete. Okay, but what is L? Another thing you're required to just focus in this diagram. Can you just see the purple color, purple highlighter? What is this showing us? Yes, we have numbering, but why it is purple? This is the reason as you have not understand about the longest carbon chain. In the chain, we have not selected the carbons which are in the branch. Do you observe this? You're required to observe this immediately when it is the carbons in the chain. So just move on with the chain. Alright? Select in the branching of the carbons. Okay? This case, this is carbon 1, 2, 3, and 4 and the same chain. So we are not required to just took above or below the carbons in the chain because it is the branching and will be causing the problems in the naming system. This chain is symmetrical, so it does not matter which way the carbons are numbered. Prefix but because there are 4 carbons. There are 2 alcohol groups on the second and third carbon as visible to you guys. So it will be 2 comma 3 and then dash diol. Di means 2, means they are the 2 groups, and 2 and 3 determines that it is on the carbon 2 and carbon is in at 2 comma 3. You are not required to just write 2 dash 3 and then comma and then diol, as I see many of candidates doing this mistakes. 2, after the numbers and numbers, between the numbers and numbers there must be comma, and between the numbers and the word name there must be the dash sign. All right. So what is 2 means diol, and at the position of 2 comma 3 means at carbon 2 and carbon 3 the OL group is present. There are no other groups, so the overall name is but 2 3 diol. All right, this is the best name. Okay, one more thing. Can you write 2,3 butanediol? This is also acceptable. All right. This is for the A level content, so we are not required to just. We are from the AS, so characteristic. Okay. Mm, Characteristic organic reactions terminology. The following terms are important in organic chemistry, so you must make sure you are familiar with them. Functional group. A group of atoms responsible for the characteristics reactions of an organic compound, homolytic fusion, all right, and heteroic fusion. This is for the A levels, for A2 levels, and for the AS levels, free radical, an uncharged molecule with an unpaired electron, initiation, an initial chemical reaction which triggers further reactions, propagation, a secondary reaction where there is no net gain or loss of free radicals, termination, the final step in a chain reaction where a reactive intermediate is rendered inactive. Okay. Nucleophile, a molecule or substance that donates electrons. Electrophile, a molecular substance that acts as an electron pair acceptor. Addition, a reaction where 2 or more molecules react to form a larger molecule. Substitution, a reaction where an atom or group is replaced by another atom or group. The one question arises here is that what is in which of the group addition and substitution acts as? Means in alkanes or in alkenes? What is acting as? Means in the wait a minute. Okay, so I'm trying to ask about that which of these reactions occur in alkenes or alkanes. In addition reaction, there is something adding. In substitution, one thing is replaced by another. What does saturation means? Saturation means everything is completed. Example of a classroom. In a classroom, there are the students. There is one more student trying to enter to the class, but there is no seat and the class is completely full. Now, this means that this is saturated class. Understand? Means complete. No space is remaining. So what I will do, I'll just take one of the candidate out of the class and will put the student who was waiting outside towards in. I have replaced both of them. This is called substitution. But if it is unsaturated, means class is having 15% of strength. All right, and there are 2 to 5 students waiting outside. If I allow them to enter, so they will be enter, and there are the seats available for them to be. This is called the addition reaction. Reaction. It means that I have added the candidate, okay, without replacing anyone because there are space available for. All right, so for alkenes, which are the unsaturated, the addition reaction occurs, and for the saturated hydrocarbons such as alkanes, the substitution reactions occur. Elimination, a reaction in which two substituents are removed from a molecule in a mechanism with one or two steps. Hydrolysis, the splitting up of a compound or molecule using water. Condensation, the formation of a compound water. Oxidation, loss of electrons, and reduction. This is what we have already discussed in the redox reactions. Shapes of molecules is very essential for you in your AS chemistry. Bonding in ethane. The shape of an ethane molecule seen on the right is tetrahedral with bond angles of 109.5 degree. This is what you are required to just remember. The bonds between each atom are sigma bonds. Rotation can occur around sigma bonds because they are formed when two orbitals overlap end to end. The diagram is visible to you guys. Bonding in ethane. Bonding in ethene. Ethene molecule have a trigonal or triangular planar shape with bond angle of 120 degree. These molecules obtain both sigma and pi bonds. See diagram as the pi bond and sigma bonds are visible to you. This we will also understand in the covalent in the bonding chemical bonding. Okay. The molecule is planar because there are restricted rotations around the double carbon pi bond. Rotation is restricted around this bond because a pi bond is formed when orbital overlap below and above the plane of atom. Alright, and bonding in benzene. Oh, okay, so this is for A levels. A2 levels. Isomerism. What is isomerism? Structural isomers. Isomers are molecules with the same molecular formula but a different arrangement of atoms in space. There are different types of structural isomerism. Chain isomerism. This occurs when there is branching on the carbon chain. Functional group isomerism. The functional groups on the carbon chain change. Positional isomerism. The basic carbon chain, the backbone, remains the same, but the groups attached to the chain move around and change position. Means now here is changing of the atoms, but the molecular formula will remain same. Understand? Taking the example, okay, isomer 1 and isomer 2. For isomer 1, you can see that there are 1, 2, 3, 4, 5. There are 5 carbons, alright? And yes, in the position, you can see that the position has been changed. Either you can keep it right there by making the double bonds, okay? And for the functional group, this is, as you can say, is ketone. For the second isomer, it is aldehyde. And you can just see this example that the atoms has been have a different means the structure is a bit different. The atoms have the different structures, but the molecular formula is remaining same. Understand? You can also write the molecular formula for them. Okay, what is this? Mm, okay, so this is stereo isomerism. Stereo isomers. Isomers are molecules with the same molecular and structural formula but a different arrangements of atoms in space. Okay. Cis trans. Okay. Geometrical isomerism is a branch of stereoisomerism. It can also be called cis trans. Okay. Isomerism. This occurs due to a pi bond with restricted rotation around the double carbon bond. Okay. Since there is restricted rotations around this bond, the various groups attached to the carbon are fixed in position, meaning different isomers can form. Examples of this type of isomerism are shown in below. See example 1 in isomerism in alkanes. First of all, optical isomerism. Optical isomerism is another branch of stereoisomerism. It occurs when there is a chiral center. Okay. Optical isomers have the same molecular and structural formula, but they are mirror images of one another. Alright, isomerism in alkenes. Geometrical isomerism is the type of isomerism that occurs in alkenes because it relies on a carbon double bond. The cis isomers has both the highest priority groups on the same end, either both above or below the carbon double bonds. The trans isomer, the highest priority groups diagonally across from each other on opposite sides of the double bond. Okay. The priority of a group is decided by atomic mass, atomic number. If the attached group is are different but the first atom joined from each group is the same, then you work along each group simultaneously until you reach an atom with a different atomic mass to decide which has priority. A higher atomic mass means a higher priority. All right. In this example, you can just see that this is cis and this is trans. And above reading, I'm just required to just make you understand that what does it means. That as you can see that they are in the carbon double bonds, the position of hydrogen uh, are not what we can record to just say is that when you can see that this is the first hydrogen on the first carbon at above, so the other hydrogen must be on the above of the carbon, so this is called cis. And at the down you can just carbon double bonds, they are the uh, function. All right, so above the carbon double bonds there are the hydrogen bonds and they must be on the same position. If there is the in the first carbon atom, if the hydrogen is below in the position, so in the second of the carbon the position must be below hydrogen atoms. This is called trans. You can see that one hydrogen is at below the carbon atom and another is on the second of the above on the second carbon atom. All right, so this is called trans. Okay. Example number 2. For the isomer below the priority group for the left hand side is the chlorine atom since it has a higher atomic mass than our carbon in methyl group. Alright. On the right hand side, the groups are similar, so you work along the chain until the chlorine atom which gives priority to the group with chlorine. Alright. So now you can just determine it. And at the last, we are also required to just understand what is a chiral center. A chiral center is an atom with four different groups bonded to it. This arrangement creates compounds which are non-super impossible mirror images of each other. If a compound has a chiral center, it will display optical isomerism. It is possible for compounds to have more than one chiral center. Spotting chiral centers. Chiral centers can be compounds by identifying a carbon atom which is bonded to four groups, such as you can see in this of the carbon you can see that this carbon is having the this carbon which is highlighted yellow is the chiral center, for only just the reason that this is having the methyl, all right, an alcohol group, an ethyl group, and a hydrogen atom. So these are the four different types of bond which are founded in this carbon atom. So this is called the chiral center. This highlighted carbon is called the chiral center. This compound displays optical isomerism. The isomers can be drawn into a tetrahedral shape with the chiral carbon at the center. It is easiest to draw these isomers by drawing one then mirroring it on the other side of the page, such as visible to you guys. And this is what I was talking about. I hope so that this may be clarified to you guys, that I know that organic compounds, organic chemistry is a bit challenging. Although this is one of the easiest chapter if you understand it once, because of only just the reason that you are just required to just draw and try to name. And many of candidates from chemistry AS has enjoyed this chapter, and I hope so that you have also enjoyed. I know that I have not drawn any structure for you all guys, but in the second video of live session, I will be promising to you guys that I will make the structures for more clarification, and I will be asking from you that name this, and required to just name it. So this is one of the interesting, and if you just take an interest and just solve the past papers, so I will think so that you'll be scoring good grades. And till that, if you does not understand anything, so just you can message me below section. I'll be replying you. And till that, this chapter is completed. And we'll be moving towards the next reactions with organic compounds, which we'll be talking about in the next session. Just so till that, take care. Goodbye.